the wash.
Oh,
Which
okay.
comes
But
here in
not by
roads.
people.
It's a natural.
Oh, so the bottom is smooth, so maybe when it took out the bottom, everything fell.
Yeah.
It looks like the water runs, because here it's like rougher.
Yeah. Look at these fragments. Big blocks in very fine mud. So here's again the situation where you're getting big blocks coming out into this lake. This time they were brought in by a mud flow, a landslide full of mud that carried big blocks with it. And the mud flow goes from about there where Allison is to about just to the top here. A certain layer here, full of fragments. It must have come in at a very high velocity and been deposited all in one day. Whereas those rocks we were looking at as we walked from the car, those were deposited slowly over thousands of years, hundreds of thousands probably. So this was one event. And this is a Precambrian gneiss. It's not Rapakivi. There are no Rapakivis here, but they're all Precambrian. All the blocks are Precambrian. They also could have come from Gold Butte, probably, but they're not so distinctive. And if you see that mountain up there, that's also a Precambrian block on top of that mountain. So there were huge blocks coming in from some direction that isn't the direction that the other sediments came from, because the conglomerates at the car where we parked didn't have Precambrian blocks in them. The rock got fractured later, and that's what made all these white gypsum fractures. So this is very odd. This looks like a glacial deposit, really. Most geologists would think immediately this was deposited by a glacier, because the blocks are sort of rounded a little bit like they get in glaciers, and they're completely unsorted from huge to small. Anyone who is just looking at this would say it's almost surely a glacier deposit, but it's 30 million, 20 million years old, and there were no glaciers in this part of the world at that time. So that's not ever discussed. It's a sort of a landslide. If we go back here and look for one layer, it's really possible. It's a thin layer here, and it doesn't have. You see, this is mud with fragments. This is part of the mud flow. But then from here to there is not mud. There's no fragments, big fragments in it. It's actually sandstone layers. It's sandstone layers like the ones underneath. And this layer got ripped up when this mud flow came. It tore up this layer and bent it and flipped it upside down. Because you can see here in this sandstone layer that it's coarsest at the top. You see it here, Dusk, maybe. Here it's coarsest at the top and getting finer. The sand grains are coarser up and getting finer down, and that's not the way they usually are. This whole thing has been flipped. So this is sand, and this is a little tiny, or coarse sand and fine sand. But there's no question about it that this bit has been flipped. So there are all kinds of things you can discover in this. If you look at these rocks, try to figure out more about how they formed and what happened.
How does mud get so hard?
It hardens because water brings in cement that deposits it. Water has dissolved minerals in it, and the groundwater moves through and leaves some as cement, and all the grains get blocked together, cemented together.
Yeah, okay.
Okay, that's all I wanted to show you here. Now, we can